So the second part of lesson 2.7, we're going to be doing just a couple examples, this example here, and then we'll look at another variation of the distance formula and the midpoint formula as we look at 3 dimensions. So I really like this question right here, this example, because it's going to involve several different things. So it says write the slope-intercept form of the equation of the perpendicular bisector of the segment with endpoints 3, 8 and negative 5, 6. So first we need to make sure we know what this is. So perpendicular bisector means it's perpendicular to this segment and it splits it into at its midpoint. So this means goes through its midpoint. And so that makes sense that we're learning this right now because we just learned the midpoint formula. So we'll be using that. All right, so let's get started on this. We want the slope-intercept form, but we know a lot of times when we write equations of lines, we start with the point-slope form. So the point-slope form is y minus y sub 1 equals the slope m times x minus x sub 1. And we know that to use point-slope form, we need a point that this passes through, that the line passes through, and the slope. So we're going to work through both these things. So we want to know a point that the line we're referring to passes through. Well, we want it to be the perpendicular bisector of a segment that goes through these points. You don't need to sketch these, but let's just look. 3, 8, 3, 8 would be here. Negative 5, 6, negative 5, 6 would be somewhere around here. So here's the segment. We want ours to be a perpendicular bisector. So it should be perpendicular and it should split it at the midpoint. Anyway, that just gives us a visual. The point is the midpoint because we want it to be the bisector, so it has to go through the midpoint. So to find the point, the y sub 1, or the x sub 1, y sub 1, we're going to do the midpoint. So the midpoint of the segment that we're referring to here, we know that is the average of the x's, so add the x values together, x sub 1 plus x sub 2, divide by 2, and the average of the y values. And so we can just put in our values, and we will get 3 plus negative 5, x sub 1 plus x sub 2 over 2, and then the average of the y values, 8 plus 6 over 2, which is pretty easy, both of these. So we get 3 plus negative 5 is negative 2 over 2, and 8 plus 6 is 14 over 2. And so the midpoint is negative 1, 14 over 2 is 7. So negative 1, 7. So we have our point that it passes through, so we'll be able to put that in here. And now we need to know the slope. Well, how do we find slope here? We have a segment whose endpoints are 3, 8, and negative 5, 6. So we could find the slope of this segment using our slope formula, but we want the perpendicular line to that. Well, we learned that if two lines are perpendicular, their slopes are negative reciprocal. So what we're going to do, our goal here is to find the negative reciprocal of the slope of the segment that we're given. And so what we'll do is we will find the slope of the segment, and we know slope is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. We can come up, y sub 1 is 8 minus y sub 2, which is 6, over 3 minus negative 5. 8 minus 6 is 2. 3 minus negative 5 is like 3 plus 5, so we get 8. And the slope of the segment is 1/4. Well, we don't want that slope. We want the slope of a line perpendicular to it. So the symbol for perpendicular is this upside down capital T, because you have these right angles here. So the slope of the perpendicular line is the negative reciprocal. So we change the sign. This one's positive, so we want negative, and the reciprocal of 1/4 is 4. And so now what we're going to do is we're going to use our point and our slope to help write the equation of the line. Let's come here and do that. So again, we're going to start with point slope form y minus y sub 1 equals m times x minus x sub 1. We're going to plug in our point. So 1 minus y sub 1, so 1 minus 7, equals our slope that we're using, which is negative 4. And then x minus the x value, so minus negative 1, which we know that's plus 1. And we can distribute, so negative 4x minus 4, and we can add 7 to both sides. And the equation of the line in slope-intercept form, that is the perpendicular bisector of the segment that goes through 3, 8 and negative 5, 6, is y equals negative 4x plus 3. So it's a good problem because we had to remember how to find midpoint. Slope, know that the negative reciprocal of a perpendicular line, the slope is the negative reciprocal. Sorry, the slope of a perpendicular line is the negative reciprocal, and then we had to make an equation of the line out of that. Last thing from this lesson is talking about 3 dimensions. 3 dimensions, well, 2 dimensions, we usually have an x-axis and a y-axis. Well, now we have this z-axis that makes us work with 3 dimensions. So we have 3 axes. These formulas look a lot alike. The distance formula looks the same, except now we have this extra part with z on there, which works out nicely. And then the midpoint formula, you're just, instead of just finding the average of the x values and the y values, you also have to find the average of the z values. So this one's going to be pretty straightforward, plugging into a formula. So find the length and midpoint of a segment connecting these points, 4, 7, 3, and negative 2, 5, negative 1. So distance, we're just plugging in. This says x sub 2 minus x sub 1. These could be switched. It doesn't matter. It could be x sub 1 minus x sub 2. So, but we'll just do it like this. So x sub 2 is negative 2 minus x sub 1 is 4. So negative 2 minus 4 squared plus y sub 2. So 5 minus y sub 1 is 7. So 5 minus 7. And then the z values, negative 1 minus 3. And that gives us negative 2 minus 4 is negative 6 squared. 5 minus 7 is negative 2. We're squaring that. And then negative 1 minus 3 is negative 4. And that's squared. So we got the square root of, this is 6 squared, negative 6 squared is 36, plus negative 2 squared is 4, plus negative 4 squared is 16. Add those together, 36 plus 4 is 40, plus another 16 is 56. So with the square root of 56, if we approximate that using a calculator, we get 7.48. So we found the length, 7.48 units. And the midpoint, we're just going to use the average of the x's, the average of the y's, and the average of the z's. So x is 4 plus negative 2. Add those together, and then divide by 2. 7 plus 5 over 2, average of the y's. And average of the z's, 3 plus negative 1 over 2. So this will be 4 plus negative 2 is 2 over 2. 7 plus 5 is 12 over 2. And 3 plus negative 1, again, is actually 2 over 2. And so our midpoint of the segment connecting those 2 points is 1. 12 over 2 is 6, and 2 over 2 is 1. So we got the distance, and we have the midpoint.